Okay, so we found margin of error, and in order to do that, we had to look up a number in table F to, to finish that out. And here it's asking us to find the minimum sample size. Okay, and what is sample size? That's your n value. So how many people or things or in your survey or in your study, that is your n value. Again, we see that little Z alpha number. So this is something we have to look up in table F. We have population standard deviation, and we have that big funky E. Well, not really funky, it's just big. So we have the big E, and that is, again, that, oops, the margin of error, okay? And again, what we put in here depends on how confident we want to be in our results, okay? More confident, the better, right? More confident, though, requires more people or things. So in order to know like the bare minimum of how many people or things you need in your study, you need to well, figure it out. And you don't want to have too few in your sample, because if you have not enough, then your data is not considered valid. Then might as well just throw it in the trash. If you don't know how many you actually need, you might end up getting way too much, and that's not a bad thing. But again, you know, this also requires time and resources. So if 350 people in your survey will get you the same results as 1,000 people would, confidence-wise, you know, you might as well just do 350. So that's when we find the minimum sample, or how many people you need, or how many whatever, we're going to use this formula. Okay. And they tell us that here again, he is the given margin of error. And it might not say it exactly, but I'll say it in a way to get that out of the question. Now, every time you have seen a value for n, it's always, always, always a whole number, right? You can't have 23.72 people in a study. That doesn't work. You can't have 0.72 of a person. So you always, 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 no matter what, if you get a decimal, doesn't matter what kind of decimal it is, very low, very high, you're always going to round up to the next whole number. So I'm going to underline this. I'm going to say it a couple times, and then some of you are going to forget. So if we get a decimal answer, always round up to the next whole number. What's a whole number? Not anything with a decimal, okay? All right, so let's find out. Here for this example, it says a healthcare professional wishes to estimate the birth weights of infants. So anybody in like the medical field might want to, you know how to do this. How large a sample, which again, another way, it's kind of counterintuitive. It says how large a sample, but it is asking for the minimum sample size. So basically, what's the sample size needed? If she desires to be 90% confident that the true mean is within 2 ounces. Okay, so that right there is telling us that margin of error. It doesn't say margin of error is, but it says that she wants to be confident within 2 ounces. Okay, that's the clue of that E value. And they give us a population standard deviation. Okay, so this is the formula. The Newton, like what they do is they distribute this squared, but I've always just done it as get the inside first and then square the result. So we have to replace a number for this variable. So again, that comes from table F, and it comes from how confident they want to be. She wants to be 90% confident of her results. So we're going to look at 90%. And then we go all the way down. 1.645. All right. It tells us the standard deviation is 8. So we're going to replace that with 8. And the margin of error is how confident she wants to be within. So that she wants to be confident within 2 ounces. So that'll be 2. And then from here, it's just a matter of putting it in your calculator correctly. So again, I recommend trying to do this in parts, maybe, might be easiest. I'm going to do the top first. So I'm going to multiply 1.645 times 8. Get that. I'm going to divide that by 2, since that's the margin of error. And then this is what I'm going to square. I'm not going to square 6. I'm not going to square 7. This is the number that I'm going to take to the second power, okay? So take that and hit your squared button, or if you want to type it back in and do that, that's fine. We get, okay, now, what did I just say before about how your final answer should be? If you get a decimal, always round up to the next whole number, okay? Now, this is 43.29. Is it closer to 43? Yeah, but 43 is too small because of this amount. We can't, you know, only take 0.29 of a baby, but we still need that 0.29 of a baby. So this is why we always, always, always round up to the next whole number. The next whole number would be 44. So she can have more than 44 little babies in her study, but she needs at least 44. Okay. So hopefully you'll remember all those little small important things. Okay. Then the next thing, oh, let's do another one since it's right there. I thought we only had one. Okay. And so here it says it's desired to estimate the mean GPA of each undergraduate class at a large university. How large a sample is necessary to estimate the GPA within 0.25 at the 99% confidence level? And then it tells us the standard deviation. All right, so we have our formula. Here, we're going to get this value based on being 99% confident, which is pretty confident. So we're going to look at 99, and then we're going to go all the way down. And might be hard to see. There we go, 2.576. So 99%, we see that our number gets the biggest. It's 2.576, biggest for that row. All right, it tells us that the population standard deviation is 1.2. So we're going to replace that with 1.2. And again, they want to have the results be within 0.25. So 0.25 is that margin of error. And then again, usually what people do, they do everything correct, and then they forget to square it. So don't forget to square it. So I'm going to put this in, 2.576 times 1.2, hit enter. That's the top. I'm going to divide it by the bottom. Okay, and I'm going to square this entire number. Don't round it. So we get n equals 152 point blah, 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 blah. All right. Again, we have a decimal. What do we do when we have a decimal? Right, we always round up. Okay, so n's going to be 153. So they need at least 153 undergraduate classes, I guess, for this large university. Okay. All right. So part of it is, again, making sure we put the right numbers in the right place, and then using the table F to get the correct number for this. Okay. So next one, we're going to do the actual confidence interval, and I'll explain that more detail. It looks scary, but it'll be okay. I promise. Sort of promise. Hopefully I can promise. All right. See you in a bit.